Hey everyone. So today I'm going to be demonstrating how to set up collision filters in the Box2D world. And I have a small little demonstration set up already, and we will be working with this. And just to forewarn you, this is more of a conceptual video rather than a coding video. It will help you get more use out of your Box2D objects by choosing what objects can collide with what other objects. And it's really fun to mess around with, and you can get some pretty interesting outputs from it. So just to run what I have right here, after I scan over it, I have a bodybuilder class that has some static methods in it, one being create box, which I use 3 times here, and I have these, the thing you really should pay attention to is these 3 bottom parts, and I should actually set these to 0 real quick. And I'll explain the method signature and I'll jump over there once I go in depth. So I create 3 boxes. This is set to false because I don't want this body to be a static body. These other 2 bodies are static bodies. And I'm just using a regular game state like I've demonstrated in a previous tutorial video dealing with a game state manager. And then I also I save that reference to the first body I create that isn't static, and I tell the camera to interpolate to it. And you can also find that in my camera section of LibGDX tutorials. So to run it real quick, let's jump right in. And oh, my battery's dying, but I'm sure won't need too much time. And you'll notice something a little different than we would normally expect from previous videos is the box kind of just fell through this other green box. And I'll run that one more time. I was kind of distracted by the battery. And there we go again. So yeah, that's kind of different. We normally observe any object collide with any other object in a Box2D world. And that's where this video comes into play and how it can be useful to choose what things collide with what other things. So this is just a dynamic body, and this is a static body, and another static body, and this box only hit this one. So let's dig in and find out why that is. And if you'll notice here, I have a few variables added in my constants file, which I tend to use for, you know, like ppm, my pixels per meter ratio, and various other things. So I have this bit player, and I also have this bit wall parameter, and then in this one I have a bit wall and another bit wall setting, and then in this bottom one I have a bit wall and a bit player. Now I'm sure you can already kind of guess if you've done any reading up on collision filtering in the Box2D world that I have set a category to this body to be a player, and I've set these ones to be walls, and then I have the masking bits set to be wall, wall, and player. And I'm sure you can already recognize why we passed through this one. So let's jump over to our bodybuilder class that I made, and you'll see here the method signature. Of course, if you want to pause the video and kind of read this code if you haven't observed how to create a body in Box2D before, I definitely recommend just kind of analyzing what I have here. So I have a reference to a world we're working with, the x, y, width, and height, whether the object is going to be a static or dynamic body, as for my ease of use, and I say whether or not it can rotate, and then I have these 3 variables at the end here in the method signature. So C bits, M bits, and G index. Now, for the most part, I'm just going to be covering the C bits and M bits, and I'll jump into the G index later. So if we go down through the code I have, you'll recognize a regular body definition setup where I set fixed rotation, position, body type, and then I have our polygon shape setting as a box, and remember to divide by 2 because Box2D likes to work from the center as a radius for any kinds of shapes it works with. And then I have something that's a little bit new that I haven't used in previous videos called the fixture def. And the fixture def is a fixture definition object that we use to set the shape, density, and collision properties of a body. Now, you can't have a body without a shape, so always set the shape for your fixture depth. Otherwise, you're going to get, I believe it's a segfault error actually, oddly enough. Like you can create a body, but if it doesn't have a shape and you create it with no shape, so if I just remove that line, it won't create it. And you'll get an error and your game will crash. But then I set the density. This is normally defaulting to 1.0, I believe. And then there's this new part, especially new part. It's a public filter variable, and that is a filter object, and on that filter object are 3 specific public variables that we have access to. Now, these are the things that we use to determine what collides with what. Now, the category bits, as you see on the right here, I have listed some analogies to help you understand more what these mean. So the category bits has an is a property, and the mask bits is a collides with property. So to kind of put it together, I'm telling this body to be set to whatever the C bits is, and I'm telling this mask bits to be set to whatever this M bits is. And so the C bits is determining what this body is going to be, and the M bits is determining what this body can collide with. And with that, you can get some really interesting interactions between your bodies in your Box2D world. Now, if we jump back over here, you'll kind of understand why certain things collided with certain things. So this one is being set to the player as the category bits, and this one is being set, or these two are being set to wall as their category bits. So I'm categorizing these 2 bodies as walls and this one as a player. And you can name these whatever you want. You can have up to 32 different categories, and I'll jump into those in just a second. So for the mask bits, I'm telling this one that it can collide with any wall object. I'm telling this one, even though it's a wall, to collide with any wall object, and that's just for demonstration purposes. And then I'm telling this one to collide with any player object. Now, that might seem a little interesting for this center one. You might be thinking, well, the player collides with the wall, but why doesn't it collide with that particular wall? Now, the reason for that is because when you're setting the category bits and mask bits, you need to make sure that if you want them to actually collide with each other, then their category and mask bits must complement each other in some way. And so I'm going to kind of demonstrate a few things as with that special property. And 1 second here, I'm just going to plug my Mac in. I guess it's going to die a lot faster than I thought it would. Okay, and so we have this player that collides with walls, another wall that collides with only walls, which is kind of strange, and a wall that collides with players. So just to show that demonstration one more time, it will build here for us, and there we go. You'll notice that it falls right through. Okay, so let's get back in here and look at this as to why that's happening. So like I said, they need to complement each other, and to really observe what I mean by that, you need to look at this top one and bottom one. So you'll see a player and a wall, and then I'm telling this player that it can collide with walls, and I'm telling this wall it can collide with players. Now, just like this wall, because I tell this wall it can only collide with other walls and not players, the player's going to do a check and be like, okay, I collide with walls, and it gets to this wall, and it's like, I collide with you. And they kind of talk to each other in that way, and this is just kind of an abstract idea to understand the concept. And the wall's like, oh, well, I don't collide with you, so go ahead and fall right through me. And the player will just kind of accept that and fall down to this, and then it'll check this filter that this body has, and it'll be like, okay, you're a wall, I collide with you. What do you collide with? And the wall will say, I collide with players, so stop where you are. And that's a little bit cheesy, but I hope that kind of helps you understand what's going on here and why that happens. So just the same, if I were to set this to player, I'm now telling that this wall, it can collide with players. So we should get a different interaction now by setting the mask bits here. Okay, and so now it's landing on that one, and that is because they complement each other in their filtering. Um, so that's just really the basics of getting your collision filtering set up. And just to go back here one more time, remember the category bits is what am I, the mask bits is what do I collide with. Now, to kind of see, you'll notice these ones up here, there's some interesting things going on. Um, let's jump into the constants real quick and see what bit wall player actually are. So bit wall is a 1, player is a 2. I have the sensor one, which is 4, no light is 8, breakable is 16. You'll notice they're all scaling by powers of 2. That is because we're working with bits, and Box2D uses bitwise operations on the filters in order to determine whether or not they collide. And if you don't have any knowledge on how bit manipulation works, or don't quite understand what bytes are, you might want to look that up. And it's a good topic to really familiarize yourself with down the road if you're planning on going to the computer science field. So I won't necessarily cover it here. For the most part, we're just going to stick to actual numbers and not be using anything fancy like this. So the next one down would be 32, and after that, 64, 128, 256, etc., etc. And you can use up to 32 different categories. If you are having troubles and need more than that, you're most likely using the categories wrong and should really slim down the way you're categorizing your objects in your world. So just keep that in mind. Keep them really, really generic, such as blocking, non-blocking, enemy, player, that sort of thing. So just be smart with these. That way you'll have less of a headache when trying to actually configure the filters so they complement each other properly. And so let's jump back over here and try out some different examples. So if you kind of notice, all we have is one category can collide with one other category. Now that's bringing down more restrictions, but there is a way to expand this. Like I said, learn a little bit of those bitwise operations and bit manipulation. It will really take you pretty far into many languages if you understand that stuff. So I'm going to use something called a pipe, or also known as the bitwise OR operation, and I'm going to set this to collide with bit sensor. Now, I'm not actually using a sensor here. This is probably a poor choice of words for a variable name, but that's just a variable category. And I'm going to change this to sensor now. And now you'll notice that I'm telling the player to, or this body to be a player, and it can either collide with a wall or a sensor. And that's how you can kind of read that as plain English, is just or. So collides with the wall or sensor. This is a sensor, and it collides with the player. So let's run it one more time with this new OR operation going on in there. And look at that, it still collides. Now, if I didn't have, yeah, I guess there's not really a situation I can break that up with. But yeah, so if I set that back to a wall, then it still can collide with the player. The player can collide with a wall or a sensor, so it should still collide. Perfect. And that's just how you can kind of chain more types of categories that it can collide with. And of course, like I said, it chains, so you can just keep going with this. You can just keep adding new ones, and you keep adding those pipes right after one after the next, and you'll be able to collide with more different types of objects. So I think now is time. You should have a basic understanding of how these work and how you set them and whatnot. Let's take a look at the group index. So the group index has 4 special properties, and I did label them down here. So when you're setting the group index, it's either going to be 0 or negative or positive number. Typically, you'd want to use something such as like 0 or -5 to 5 or something, just keeping them small because it adds a lot more versatility to these category bits and mask bits. So um, by default, the group index is 0 to all Box2D bodies. So if you don't plan on using group index, don't worry about setting it. You don't have to. But if if it is 0, then it's just going to continue using these mask and category bits as normal. However, if the group index between two bodies are non-zero, but they are not in the same group index, so if the group index is different for each one, like one is -1, the other one is +1, then it's just going to continue using the category bits and mask bits as the collision rules for your, or in your world. However, if the group index is the same and they're both negative, so let's say two bodies have the group index of -1, then they won't collide no matter what. It will completely ignore the category bits and mask bits between them, not between other objects, because of course it still relies on the group index and the category and mask bits. So if they're the same and negative, they won't collide no matter what. This is ignored. However, if they're both positive, then they will collide no matter what. So again, it's ignoring this. So essentially, if they're the same and they're negative, won't collide. If they're the same, positive, then they will collide no matter what. And if they're both 0, then it just goes back to relying on the mask and category bits again. So to kind of observe that, we have the bit player and bit wall for the first object, and bit wall and bit player for the last one. I'm just going to kind of, oh no, I'll leave this one in. So this center one still collides with all objects, and we're just going to set it to -1, and we're going to set the player object to be +1. So if you remember, if they're non-zero but they're not the same, they shouldn't collide, and it'll just, or I'm sorry, they will just use these mask and category properties. So what we should observe is it should still collide with that second body, and that's exactly what we got. So now let's change the player to a group index of -1 and observe what happens there. Even though they are supposed to collide with each other from the mask and category bits, it fell straight through, and that's how you can observe how the group index works. And again, if they are +1, and let's say even this one doesn't even collide with sensors, so, or this one doesn't even collide with players, it collides with sensors now. You know, let's just make it a sensor itself. So it's entirely different than what we'd expect otherwise, but they have the same group index and they're both positive. So let's check that out real quick. And look at that, they still collide. So that's following true through the 4 statements we have down here on the group index info. So with that, I hope you've kind of gained a more familiar understanding with the collision filtering in the Box2D world. Of course, if you have any questions, leave it down in the comments, and in general, just comment, like, subscribe as usual, and I hope you enjoyed the video. Thank you.